Hi, and welcome back. So in the last video, I went through this example, and this example to kind of illustrate what it is that we're asking for in a limit. And actually, one mistake I made, this should have been the limit as x approached 0 of x over x. That's what I was meaning to say. And I guess what I want to do in this video is I just want to clarify, maybe give one more really simple example, and I want to clarify the notation just a little bit. So I'm actually going to clear this off and give myself a new layer. And so what we're going to, pretty much what we saw in the last video is I gave you that specific example of x over x. And I want to say, I just want to really generalize the form that we're going to see in these limit problems. So what you're always going to see in the limit problems is you're going to see LIM, which is the limit, as some variable, and it's normally x, so I'll just write an x right there, as x approaches some constant, and we're just going to call that constant a, of some function. We're just going to call this f of x. So if you remember from the last video, we were saying the limit as x approached 0 of x over x. That was our function in the last video was x divided by x, and the value that we were approaching was 0. And so pretty much, if you remember from the last video, what I said that we were asking with this notation, what this is asking for is what does f of x approach as we get numbers really, really close to a. So sometimes you'll see that written as, well, anyway, I might be getting ahead of myself, but a positive is meaning, numbers that are just a really, really, really little bit bigger than a, or we could also have a minus, meaning numbers that are just really, really, really just a little bit smaller than a. So that's kind of what we're looking at. And particularly if f of x is undefined at a, we can sort of maybe make an approximation, and eventually you'll see that we can actually definitively say that, say what would the function be if it were defined at this point. So anyway, let's actually do another example. I'm actually going to erase that right now. But anyway, we're going to do another example with limits. And this one's going to be hopefully pretty easy. And the problem is going to be, what is the limit as x approaches 2 of x squared? So now our a in this expression is, and let me switch back to the a color, our a is 2, so that's the constant that we're approaching. And our function right here is x squared. So what does that function look like? Well, there's x is equal to 1, and y is equal to 1. It looks something like this, where we have at 1 and -1, the function is equal to 1. And then at 2, the function is equal to 1, 2, 3, 4 up there, and 4 when x is -2 as well. And so we have this, and I'll probably not do that great a job drawing this, but we have this parabola. And the important thing, and this will come into play, I don't want to get too ahead of myself for right now. One of the things that you could kind of notice when I drew this parabola, and it looks, I didn't do a great job of drawing it, but one of the things that you can notice when you draw a parabola, or when you draw a line, like say if we had a line, I don't know, y is equal to x. If I were going to draw the line y is equal to x, I could do that without picking up my pen at all, right? And I don't want to get ahead of myself, but anyway, that's an important thing to just realize right now about maybe this line y is equal to x, and also this parabola x squared. And we're going to use that more in a future video. But right now, just realize that if I were drawing y is equal to x, or if I were drawing this parabola of x squared, I didn't have to pick up my pencil at all. I could have just drawn it in one swoop. There weren't any points that were undefined along that parabola. So now, anyway, let's go back to this limit. So this limit is asking us, as we choose numbers that are really, really, really close to 2 on either side, either just a little bit less than 2, so right here, or a little bit more than 2, and we keep choosing smaller and smaller numbers, or numbers that are closer and closer to 2, then what is our function going to approach? What is our function going to approach from either direction? And you can probably see right now that we have and I haven't defined what this is yet, but we have a continuous function. There aren't any points on this line, there aren't any points on this parabola that are undefined. And pretty much each value along this curve, along this parabola, is kind of leading into the next one. Or if we go in the opposite direction, as we choose smaller and smaller values, we kind of, as we choose smaller and smaller values, we have a continuous value. So it's not like we have a big jump of values anywhere. So as we approach from either direction, we kind of have this continuous line, right? So really, and that's kind of the intuitive way to think about saying that the limit as x approaches 2 of x squared, that this is really just going to be equal to, and you can see that there's no reason that 2 is undefined for x squared. So this is really just going to be equal to, and the limit of 2 squared. Just like if we plug 2 in for x. And what's 2 squared? That is going to be equal to 4. So, and maybe it's a good thing to just think about what that means with the definition of the limit that we talked about in the previous video, where we said that we're just trying to choose values that are closer and closer and closer to 2. But in this case, it's fine for us. We could choose the value exactly at 2 because there's no reason that it was undefined. In the last video, we were saying we had the function. In the last video, let me just go down here. Remember, we were looking at the limit as x approached 0 of x divided by x. And there was a reason that we couldn't just exactly plug 0 in, because if we plugged 0 in, we would get 0 over 0, and this is undefined. So now, in this expression, there's no reason that 2 squared is undefined. 2 squared would definitely be a defined number. And this is a continuous function, which I know I haven't, I guess, rigorously defined continuity yet, but pretty much you can think of this function being continuous just because I was able to draw it without lifting my pen off of the paper, or off of the, I guess, electric blackboard. But pretty much, I guess, that's the intuitive way to think about these limit problems. We're not even really, and remember again, we're not caring about what does this function x squared actually equal if x is equal to 2. All we care about is what does it approach. And you can kind of see from this graph that it is approaching 4 right there. So anyway, I think that's enough for this video. Hopefully that helped you understand a little bit more about limits. In the next video, we're going to start doing maybe a few more examples and maybe have the examples get a little bit more in-depth. Thanks for watching, and I'll see you soon.